Hi everyone. Today we're going to study general solution of non-homogeneous differential equation. We're going to find particular integral when capital X equals e raised to ax. The general form of a non-homogeneous linear differential equation with constant coefficients is given here. We consider this to be equation 1, where a sub 0, a sub 1, a sub 2, up to a sub n are constants, and capital X is a function of x or a constant. Also, capital X is not equal to 0. The general solution or complete solution of equation 1 can be obtained by finding the complementary function and particular integral. In symbol, we write y equals cf, that is the complementary function, plus pi. This is the particular integral. Let us determine particular integral. This is the general form and the method of finding pi or particular integral when capital X equals e raised to ax. This is the formula. Pi equals 1 over f of capital D times e raised to ax. This e raised to ax, that is the right side value of the general form. Then we're going to evaluate this f of d with respect to the value of a. Take note that the value of a is the coefficient of x in the exponent here. This is now the value of pi. But it must be that f of a is not equal to 0. In some problems, the f of a equals 0. In that case, we will proceed with the next formula, and that is we multiply this value here by x. It means we multiply this one by the x, and in the denominator we take the derivative of this with respect to d. So it becomes like this. The pi equals x all over f prime of d times the e raised to ax. After this, we evaluate the f prime of d by the value of a. This is now our value for the pi. Again, it must be that f prime of a not equal to 0. On some problems, this f prime of a will be equal to 0. In that case, we will come back to this value. We will multiply the numerator again by x, and then we take derivative of this first derivative. So it means it becomes second derivative. So the new formula for the pi is equal to x squared all over f double prime of d times e raised to ax. Then we evaluate the second derivative with the value of a. So the formula becomes like this for the pi. Again, we said that the f double prime of a is not equal to 0. So the pattern is like this. Suppose in this expression, the denominator is equal to 0. What we're going to do? We multiply the numerator by x, then differentiate the denominator with respect to d, and then replace d by a. We continue that process until the denominator is non-zero. Example 1, solve the equation. Second derivative of y with respect to x minus 3 times dy over dx plus 2y equals e raised to 3x. Our general solution is y equals complementary function plus particular integral. Let's begin with finding the complementary function. Using operators, the equation here becomes the quantity d squared minus 3d plus 2 multiplied by y equals this right side e raised to 3x. The auxiliary equation now becomes, we change this d by the m. So m squared minus 3m plus 2 equals 0. Let us solve for the m. We do factoring. So we have m minus 1 times m minus 2 equals 0. We equate each factor into 0. We have m minus 1 equals 0 and m minus 2 equals 0. So the values of m are m sub 1 equals 1, m sub 2 equals 2 respectively. We can see that we have two real and distinct roots. So the formula for the CF is like this. We simply substitute the values of m sub 1 and m sub 2 respectively. So the CF is equal to c sub 1 times e raised to x, that is m sub 1 equals 1, plus c sub 2 times e raised to 2x. Our m sub 2 is equal to 2. We just copy the value of CF in here. Then we proceed to find the particular integral or PI. Our formula is 1 over f of d times e raised to ax. Substituting the values, we have now 1 all over d squared minus 3d plus 2. Our e raised to ax will be e raised to 3x. Then we change the value of d by a. The value of a is 3, so we have 1 all over 3 squared minus 3 times 3 plus 2. When we simplify the denominator, it becomes 2. So we have 1 over 2 times e raised to 3x. This is now the value of pi. So for the final answer, we combine the CF plus pi. So it becomes like this. This is now the final answer. Example 2. Solve the equation second derivative of y with respect to x plus 2 times dy over dx plus y equals e raised to negative x. The general solution is y equals CF plus pi. Let's begin with finding the CF. Using the operators, we write the quantity d squared plus 2d plus 1 multiplied by y equals the e raised to negative x. Using the auxiliary equation, we write now m squared plus 2m plus 1 equals 0. Let us factor the left side to find the values of m. So we have m plus 1 times m plus 1 equals 0. We equate the factors into 0, m plus 1 equals 0 and m plus 1 equals 0. So the values for m1 will be same, and that is equal to negative 1. We can see that we have two real but equal roots. In this case, our CF is equal to this formula. Let us substitute the value of m sub 1 in here. So our CF becomes like this. Let us copy our CF somewhere here. Then we proceed to find the PI. Our formula is 1 over f of capital D times e raised to ax. We substitute the corresponding values. We have now 1 all over d squared plus 2d plus 1 times the e raised to negative x. Then we evaluate the denominator with respect to a. Take note that the value of a is equal to negative 1. So the denominator becomes like this. The square of negative 1 plus 2 times negative 1 plus 1. When we simplify the denominator, it becomes 0. It means our fraction here is undefined. We will go to the next formula. So that is the pi equals, we multiply this expression by x, and then we take the derivative of the denominator. So it becomes x all over, denominator is 2d plus 2. Again, multiplied by e raised to negative x. Then we evaluate our denominator with respect to a. The value of a is negative 1, so we have x all over 2 times negative 1 plus 2. When we simplify the denominator, it becomes 0. Again, our fraction is undefined. Let us go to the next formula of pi. That is, we multiply this expression by x in the numerator, and in the denominator, since this is first derivative, we go now to the second derivative with respect to d. We take the derivative of this 2d plus 2. So the expression now becomes x squared all over 2 times e raised to negative x. Then we evaluate our denominator with respect to a. But since our denominator here is already constant, we will just copy that same value. So x squared over 2 times e raised to negative x, this is our pi. So we are now complete. The CF is here, the pi is this value. We just put it together. So the final answer is y equals the CF plus the pi. This is now the final answer. I hope you learned something from this video. See you again next time.